So yeah, as I mentioned, so this in this room we will hear from Vaibhav about how they use machine learning at Klarna. Vaibhav is the senior data science manager at Klarna. Klarna is Europe's most highly valued fintech startup, processing more than 1 million transactions daily. And Vaibhav has been in the field since 2015 and was a software engineer before that. So he holds a Master of Science in Communication Systems Engineering from the University of Portsmouth, UK. And yeah, so welcome. And I'm looking forward to hear your presentation. Yeah.
Thank you, Corrie, for the nice welcome. Hello, everyone. Very nice to see you all. Let me share my slides and then here. I will try to make this a bit more interactive rather than making it a monologue. So please ask me questions when you feel like it. If you think that I'm speaking too fast or I'm covering topics too fast, let me know. All right, so what will we learn today? A bit about an introduction of what Klarna does. What do we do in terms of credit risk, fraud risk? What other fields do we also work on when it comes to machine learning applications in Klarna? And finally, a bit on the actual architecture systems. So first thing, so my name is Vaibhav. I head the data science in Klarna's Berlin office. I'm more or less in charge of the fraud modeling projects in Klarna and also the app personalization teams. So what is Klarna? I hope, or at least I hope most of you have already used Klarna. If you are based in Europe, if you're not based in Europe, probably not. But Klarna, in all essence, is a payments solutions company. A bit of Klarna facts. Klarna is currently valued since last week around $10 billion. In my personal opinion, it should be valued even more because our competitors are a bit more highly valued than us. So it might grow in the future. I guess it will be around 25 billion in the future or close to 50, but let's see. I can't say much there. We are around 3,500 employees or more, and we are still growing. COVID didn't stop us. COVID kind of made us even bigger due to a trend of online sales and online shopping behavior. We have around more than 200,000 merchants integrated with us and also continuously growing. And of course, since we have so many merchants, we have a lot of transactions coming to us every day, and we process around 1 to 1.5 million transactions daily. And during Black Friday, it goes from 1.5 to 2.2 million transactions during the Black Friday or any special events. Okay, next. So as I said, Klarna is a payment solutions company. What kind of payments products do we have? We offer pay now products where you pay to Klarna using your credit cards, debit cards, or instant bank transfers. Then there's pay later, where you pay in 14 days time, 30 days time, depending on how long the merchant takes to transfer the products or ship the products. Then we have slice it options where you pay in installments if the purchase or if the transaction price or transaction price is higher than what you would like to pay in one go. So let's say if I buy things through IKEA, you would like to pay in installments. If you buy flight tickets to other continents, those might be pricey, so you might like to pay in installments. I think I kind of skipped a slide, but I'll tell us anyway. So it's a payment solutions company. Why do merchants or why do consumers like us? One thing is there are several options outside. So Klarna, there's PayPal, there's Adyen, there is Stripe. Why would someone choose Klarna? So basic answer is Klarna takes the overall risk behind the transaction. As soon as the checkout happens through Klarna, Klarna owes the money to the merchant, and that is why the merchants like us, because they do not have to rely on late payments or defaults from the consumer. From the other side, why would a consumer choose us versus other payment methods or payment solutions companies? Basically because of different payment options. You have guarantee of getting the product. You can try our products before before moving the money from your bank accounts. So this gives a kind of a guarantee to both the sides of the coin, and this is how we increase the conversion rate on the checkout flows. Then comes the credit risk part. So since we are giving out or facilitating transactions more than 1 million every day, million in count, volumes are in billions, we are taking a lot of risk on Klarna in terms of giving out loans. Even if you buy things through H&M for 10 euros, it's not your 10 euros, there are a million more transactions happening at the same time. So what do? We have to be very stringent on what kind of customers do we choose to let's say give out loans to. So how do we define a credit risk? This is a very old mathematical formula, and all the banks kind of use this. What we do in terms of Klarna's machine learning is basically doing the probability of default. We need to identify for a particular transaction, and for this particular customer, what will be the probability of default. So this is the machine learning part of it. Then comes the exposure part. Basically, exposure is at the time of a default, what is the outstanding amount that the customer owes us. And finally, the loss rate, which is basically how much losses we will make at a particular point of time if a customer defaults. So loss rate is basically 1 minus recovery rate. Recovery rate is at the time of default, how much money, if the loan goes to default, how much can we actually recover? I hope no one has been into defaults or in debt collection yet, so good things there. Never go there because it's a very bad path and things go ugly behind the scenes. So anyways, so these are the definitions. You can read it later if you want to, or you can ask me questions. Everything clear at this point, I hope? Then comes, what challenges do we face in Klarna when it comes to credit risk? The first thing is target data. So for training a machine learning model, of course, more or less, the models that we make in Klarna are supervised models. That means we need to have targets in place. Targets for machine learning is not easy, as you will see from any other presentations today, or as we have seen, getting the targets is the most difficult job. When it comes to credit risk, it is not like you get let's say on day 14, if you do not pay to Klarna, we do not put you as a defaulter. Every company will give you some leeway to pay us back. Your transaction might go into to debt collection, and you might pay us back. So that means you're not a defaulter, but then you have paid us back in a certain period of time during, let's say, 6 months. So getting these targets is not easy for us. So if you want to train a model today, we'll have to go back 6 months behind in time to get the data sets. Secondly, credit products. Klarna, so the products that I showed you, they are like 2 of the products that I showed you. There are many more products that Klarna offers. If I start talking about all the products, this session will not end today. So keeping it short, we have several credit products, different payment options, different timelines of payments, and to create different kinds of models, it's kind of difficult because we need to figure out which customer went through which journey, what product did the customer finally came to, and to create different data sets, that is the issue. Also, customers can move during their life cycle, they can move from one credit product to a different credit product. That means, how do we define which target we should follow? Should we follow an installment product? Should we follow a one-time payment product? So these are the questions that our data scientists need to talk with stakeholders to identify what they need to do. Thirdly, credit scoring partners. Klarna is a regulated bank, and in many countries, we need to, when it comes to regulated products, we need to actually use some regulated banking or credit scoring agencies. And let's say in Germany, we use Schufa and many others. So depending on different credit scoring partners, we get different kinds of information. And these are not normalized. They come in different sizes and different forms. And as a data scientist, then comes the part of cleaning. We need to clean up all this data. We need to normalize. We need to identify which columns, what kind of data do we want from the credit scoring agencies. So this is a bit problematic for us. I've already explained consumer switching between different credit products and messing up with our targets. Yeah. And then, of course, we are making decisions, right? So we are doing credit risk decisions. The more amount of data that we have, the better decisions we'll be able to make. But asking more information from the consumer also increases the friction on the checkout flow. And Klarna's motto is smooth. They want your transactions to happen in one click. So if you buy things through Klarna and use Pay Later, it's just one click. They will only ask your date of birth, your maybe email address is already there, date of birth, and your name, and you say buy now, and your transaction is successful. A lot of things happen behind the scenes on how we collect information from the checkout forms, but this is Klarna's way to do it. Of course, we would like to log into your bank accounts, get more information about your daily transactions, what you have done in the past, but yeah, we can't do that. So with limited information, we have to make a lot of decisions. Any questions so far? If not, then let me finish the monologue then, and then you can ask me more questions. Next thing is fraud risk. Okay, so credit risk is done. We have kind of identified you're the real person and you want a loan from us. It can be 50 euros to 10 euros, whatever the shopping cart amount is. Next thing is fraud risk. When it comes to fraud risk, we need to identify what kind of fraud we are dealing with in Klarna. In general terms, fraud happens in three types. First party fraud, where you as an individual are the rightful transaction owner. Let's say I am buying things through H&M, but I really do not want to pay H&M. I bought an item or dresses and suits, whatever I want. I put 1,000 euros of items in my shopping basket. I bought everything through H&M, and then I run away from this country. That means I really do not want to pay for my product, even though my Schufa score is really good, my credit score is really good. I'm a really good customer. All my identification is done. KYC is all good, but I really do not want to pay. So this is what is called as a first-party fraud. Happens a lot in the US, just for demographic information. Then comes second-party fraud. Second-party fraud is where you sell information to a fraudulent person. Let's say there has been frauds happening with IKEA payslips. IKEA, let's say, the receipts that you get from IKEA. People try to defraud IKEA by getting returns or the actual money by showing receipts. So they will ask you for your receipts. They will, let's say you have a receipt for 2,000 euros. They will give you 50 euros or 100 euros for your receipt. And then they will go to IKEA asking for refunds. So this is where you as a genuine customer sell your details, sell your identity, or sell your receipts to a third party. And then finally, third-party fraud, which happens mostly in Klarna's terms. This is where someone steals your identity. In typical terms, let's say I've dealt with credit card frauds myself personally. My credit card details were stolen by someone. They were making transactions. Of course, I had Visa. I had to reclaim money from Visa, but this is where the problems exist. Third-party fraud. And Klarna being very smooth in the checkout flow, it happens that we have a lot of third-party fraud, because if I steal your identity from let's say from the black market, from companies where their details have been stolen, I can easily make a purchase. Can't share more details on that, on how third-party fraud is done. Talk to me in person if you want to know more. Okay. So details are there if you want to read out later on. Then other use cases in Klarna. Other use cases in Klarna are mainly first in debt collection. We would like to identify when do we want to put a customer into debt collection flows, what kind of communication we should have with the consumer at what point of time. Second one is customer identification, or which, let's say, is very important for us because we would like to identify if you're a returning customer or not. Typically, let's say I live on Skalitzer Straße, I can write my address in different forms in Germany. Sometimes merchant sends us first name as last name as first name. So there's let's say there is no perfect nomenclature of what a checkout form details would look like. So we need to have machine learning behind the scenes to identify if you're a returning customer. Then customer returns. Customer returns is also a big problem for the merchants. Since you're using Klarna, you have the ability to test out products. And once you test out products, or you have the ability, let's say, you will order, let's say in fashion terms, you might order the same product in different sizes or in different shades of the color. For merchants, it's a big problem because they are paying us a commission on the shopping basket, plus also handling the return costs. So now they have two operational costs on them. And this is where they ask us to return some part of the money to them because they do. Let's say you ordered 5 items and you only kept 1 item, they would like to get the money back from a merchant perspective. So this is where we need to find out abusive customers who are trying to abuse our shopping carts. Then comes payments personalization. This is where we personalize what payment options we show on the checkout. Let's say your transaction amount is high, we would put installment products on the top rather than payment on the spot. This also depends on your past behavior and your current transaction amounts and your current transaction basket. Then comes Klarna is a bank. We are regulated. We need to abide by the regulators' policies in different countries. We need to forecast revenues, capital reserves, losses, and give them regular feedback to these regulators. Then comes app personalization, which I'm also kind of responsible when it comes to home feed personalization. This is recently launched in Germany, so you can check out the Klarna shopping app. Basically, you can shop on the app. You are shown different kinds of products. You can click on the products, and then you can basically shop from the merchant. Then comes marketing and campaigns. Marketing, if you would see recently again in Berlin, if you're living in Berlin, I saw day before yesterday a lot of big hoardings of Klarna on Alexanderplatz. They do not just happen to be there. There is a lot of analytics and data science happening behind the scenes to see where and how do we acquire customers from. And of course, campaigns. These comes as emails to you or through campaigns, letters, different things, different campaign management. There are much more than that, but I couldn't fill everything. And of course, this monologue will not last 10 minutes. Then comes decisions in real time. This is basically the fun part of the presentation, and then you can ask me more questions. So we are handling millions of transactions every day, and there is not one decision happening in real time. There is credit risk decisions happening. There is identification happening, credit risk decisions happening, fraud risk decisions happening, payment personalization happening on the flow. So there are many teams involved when you click the buy now or when you see the checkout forms. And this is all happening in real time. There's no batch. The batch products are mainly happening on debt collection pods, or when we say, when we give out information to the regulators. Apart from that, most of our decisions that we do in Klarna are done in real time. So when we talk about real time, let's talk about a bit on how do we do model generation. So this is a typical generation flow from fraud modeling. You would see that more or less the steps in pipeline are done by many. You would have done it if you're a machine learning practitioner. These things can be done in one machine, can be done in several machines, can be done on Airflow jobs, can be done on step functions on Amazon. You have so many options. We give our data scientists all the freedom to choose what kind of options they would like to have. Typical flows are you extract the data sets, you create your features on top of it, you split the data sets, you pre-process the information, and then you start training, and then you follow other processes where you calibrate if there is a need, you display performance because there might be stakeholders who would like to have performance reports, and then you create all these fancy reports for them. So typically when it comes to the first phase of modeling or the exploration modeling, then comes you would like to have features. You might not know what feature types there are if the data is unstructured. In Klarna's case, we get information from different sources, different checkout teams, different payment products. So it is our case that the data types of certain columns are not consistent. And maybe there are none columns, there are NAs. So if you use pandas, it might just say it's an object. It doesn't know what to do. Or there might be inconsistencies in the data set. So you need to have proper data types on the columns. And then comes the feature engineering. So feature engineering, let's say you have 10 features now, you might want to include 2 more features, but then you have past years of data to pre-process. So what would you do? You would not need to create features on top of that. So all this is kind of done on SageMaker for us. Klarna's infrastructure is basically AWS. All our products are served through AWS. From machine learning flow, most of our training pipelines are done on SageMaker, and hosting is done on a different platform, which is, let's say, proprietary to Klarna. We do not use SageMaker hostings as of now, but maybe in future. So from the exploration phase, we use a lot of SageMaker pre-processing jobs, and then we use a lot of hyperparameter optimization jobs. From these processes, what is happening is we are getting generated features, we are getting proper D types, all cleaning is done here. And once we are stable with our models, once we are stable with our hyperparameters, then we use this model to generate every 2 weeks, every month, whenever we see a model drift happening. And all this time, all these reports are created. Once we see the reports and once we see that model is behaving better than before, then we deploy those models. So this is kind of a typical model generation architecture. I've made it very simple. Different teams, they use their own flows. I'll not go more in details there. If you have questions, please feel free to ask.
So there have been so far no questions in the chat, but I actually have quite a few questions. So you're saying that you use AWS for all your modeling, pre-processing, etc. So I was wondering, so because you say you're also a bank, so I assume anyway in this field that there's like high regulation. Do you have any problems, or was it difficult to fulfill the regulations to be able to use AWS? I mean, also recently there have been quite a few discussions about sending data abroad to America.
Mm-hmm. Yes, so this fortunately happened before my time. So someone else solved this problem. So I joined Klarna like more than 2 years ago. At that time, this problem was already solved. Before Amazon, we had proprietary, or let's say, data banks in Stockholm caves. At that time, let's say Klarna was not that big. So we used to have caves in Stockholm in 2 places where we used to have data centers, and all our machines used to be there. These are typically data centers where you have to buy your own machines, go into these caves, put your machines there, and then you run those machines. But yeah, of course, it doesn't scale with Klarna's scale on merchant acquisitions and customer acquisitions. So we had to find out cloud partners, and Amazon, at that time, someone would have evaluated Amazon, Google, or whatever, and then they went for Amazon. So at least I didn't do that. But still, let's say if you want to use new Amazon products, or let's say if you want to integrate other products through Amazon's marketplace, we have to do proper NDA, proper legal, proper data governance objectives before we can try out any let's say new solutions, even from an Amazon marketplace. Of course, there are companies which want us to integrate with them directly, which is a bit more problematic. But yeah, it's a bank, it's regulated, we need to follow all the processes. It's not a startup where we can do your job in one day.
Okay, so there's one question from the chat. So regarding the deployment, so after retraining, the decision to deploy new or to keep the previous one, is this automated in SageMaker? So do you like automatically deploy the model after retraining?
Yes. It is, let's say, automated till the sense that when you see the reports. Once you see the reports, once you're happy, then you press the buttons to deploy the models. You do not just deploy out of the blue, because you're making decisions on real time and you're affecting customers. You can't just, let's say your model is not behaving and it starts rejecting a lot of consumers. Klarna wants to make money in the end. It will have a lot of opportunity cost if you make that decision. Let's say you make decisions to accept everyone, then it might be the case that Klarna starts accepting a lot of defaults or fraudulent behavior or fraudulent customers. Klarna will lose a lot of money. So we need to be really diligent once we deploy those new models. Yeah, the training can happen automated. This is all automated training happening behind the scenes. But when it comes to deployment, there is definitely a human in the loop, us basically, who make that decision.
Okay, so there's another question. So if you considered like exploring alternatives of generic credit scores for decisioning and risk management process, so and that if there are certain problems with like traditional methodologies like diminished predictive power or similar.
Can I see the chat so that I can at least read?
Yeah, it's from Sebe and Bazi.
Alternate generic credit score for decisioning. So first question is yes, exploring alternate. I can tell you more about the features. Maybe let me cover the features and then I can answer this question. Okay. When it comes to features, what kind of features do we have? We have transaction features where we know what you're trying to buy. What is the item price? What the individual items are? What is your shipping details? What are your billing details? So basically everything that you enter on the checkout form. Then we have, if you're a returning customer, we know how many times you have purchased through Klarna, how many times you have paid us back, how often, what was the delay in payments, and so on and so forth. Then we have information coming from the merchants. What default rates or what fraudulent rates they are seeing in their platform right away. Typically, it happens that once a merchant, let's say I'm a merchant and I start giving out discount coupons or gift cards. And if it was not there before, people would try to use Klarna to buy these gift cards and sell it on let's say eBay Kleinanzeigen or something else. Do not buy tickets, event tickets from eBay Kleinanzeigen on any platform, because it might be the case that these are fraudulent tickets, unless you can verify and you trust the seller. So there might be risky items. In this case, let's say discount coupons, cards, shopping cards, and gift cards. These are all riskier items. Then comes graph information. Graph information is how are you connected to previous payments? How are you connected with a default payment? How are you connected with a riskier customer? Maybe you're living close by, maybe you're living far away. Everything is linked to somehow or the other. We have this information, so this is what we call as a linking feature for us. And we use all these kind of features to make these, let's say, models. Then comes, let me finish the slide again, and then I'm done with the slides, and then I'll answer all your questions. Then basically, so the models are all out there on an ECS, managed ECS. So they're all doing their jobs on a container base, but we need to create all these features in real time. Let's say I go to H&M right now and I buy a t-shirt for €10, and then again I go in 15 minutes time and I buy another item from H&M. We in Klarna would like to know, how many times have you paid before? How many times have you bought things through us? So we need to take into account your previous transactions through Klarna. You can buy again and again from a merchant in another minute, in another second, but we need to have all this information in real time. So once we create, let's talk about a very typical feature. How much do you owe to Klarna? I buy one item right now for €10, and in the next second, I buy another item for €20. Let's say you buy another item in the third second or the third, let's say next minute, we would like to know how much do you owe to Klarna. So you now owe €30 to us. And there are many kinds of these features where these are, let's say, counts, or let's say what we call in feature terms velocity. How many times have you done a certain activity? What is the count? What is the mean? What is the average on a certain fee? So there's some kind of proprietary information here, but yeah. Information that we get from different teams is all done through Kafka. They are done converted to Kinesis, and then this is where we filter out what we would like to get from different, let's say, message queues, what information we would like to extract. Then we create an events table, and from an events table, then we create a state table. State tables are basically for a person, we would like to calculate some metric or let's say a feature, and this is what is a state table. And these are being calculated in real time and then served through basically lambdas in real time. There is a bit of EMR happening behind the scenes, because maybe we would like to backfill, we would like to explore new features, and this is where we use PySpark to create new features and to evaluate new features. And once that is done, we can push this to an S3 bucket, and this is where SageMaker can pick new features. And basically that is the end of the slides. Now going back to a question from Sybil. Exploring alternative generic scoring. So yes, so these are the features that I say here. These are not, let's say, in banking terms, these are not typical features. These are all alternative features. Linking counts of transactions, how customers are connected. We are exploring new features as well in terms of going to your bank and getting information for your past 3 months of transactions, what you have done. So these are, let's say, called alternative features. We also have, no, I will not tell. We also have scores coming from social media platforms here and there, which I cannot disclose much. But yeah, we have a lot of alternative features for us. Then there are certain, any question?
Well, I would say, so we are almost at the end of our meeting. So so there were 2 more questions that maybe we could answer before. I mean, if you have any last minute question, so maybe we can then also. So one was about the different cloud services. If you compare AWS, Google, and Azure cloud services, especially in terms of ML speed and efficiency.
The thing is, yeah, we can explore, but then I've been in many bigger companies, but when it comes to exploring these solutions, the main question comes down to the main question, or the main bottleneck is, where do you store your data sets? Once you're locked down with a company, Amazon, and once you grow with the scale as Klarna or Naspers, my previous companies, once you're locked down with your data set in one of these cloud providers, you're basically stuck. Yeah, of course, we have all our solutions made on containers, and we can deploy our solutions anywhere. Yeah, people say that, but moving data from one source to another source is also difficult. And when it comes to banking, it is not easy. So yeah.
Yeah, I assume like on top of the containers, you also still need to configure that the containers are run how they're supposed to. So then 2 more last questions, and I think then we close it up. So one, I think it's the first one, if you are using Neo4j.
No, we are not using Neo4j. We are experimenting through Amazon Neptune, which is a solution from AWS.
Okay. No. And final question is, how do you monitor model performance?
Modeling, so these are from different teams. There are different performance metrics that we monitor. Let's say a typical would be your mean, let's say mean score, okay? Mm. When it comes to model performance, first it depends, are you doing regression, classification? Let's talk about fraud, right? In fraud, we need to have precision recalls, and we need to monitor this during the training and validation phases. When it comes to model drift analysis, then we need to figure out what kind of metrics we need to have in place so that we can get alarms, or how do we identify if there is a drift happening in the transactions. In those cases, we have mean model scores, and we see how much there is a drift happening. These drifts can be happening on an overall score, or they can be happening on the feature side itself. Maybe there is a fraud attack happening on a consumer, so the transaction amounts or the shopping basket sizes have increased. So these things also differ. So we monitor both the features and the models. Jisan was also asking me a question in terms of speed, of ML speed when it comes to different services. I haven't used Azure yet professionally. I've used Google Cloud and Amazon AWS. When it comes to speed, they're all milliseconds. It depends on how you deploy your applications. Once you deploy your applications on Amazon Fargate or AWS Fargate or Google ML, these are really, really low latency. So you don't have to worry about them. They are all managed. You can be safe there. And then it depends on what kind of model you have. Is it an ensemble of models? Is it a sequential model, one feature going to another model? So in Klarna, we also do a lot of model testing, let's say load testing. How many transactions can it have? Can it handle in a second? So this is what we'll do. Any other questions?
I think you have a question, Danya?
Yes, I was just interested in the load test that you just mentioned. Do you also use some AWS solution for that?
No, these are proprietary solutions or teams handling this for us, because Klarna really needs to scale up, let's say, for Black Fridays. So typically right now, Black Friday is coming in November, and all the teams now need to already create plans on how many more resources we would need from Amazon, because we cannot just go to Amazon on the last day of things, and then we need 1,000 or 2,000 new machines, and Amazon would say, sorry, we do not have so many machines allocated for you. So we already need to forecast how many more machines do we need for Black Friday, so we can acquire those reserved instances from Amazon. These are based on, let me see if Locust is an open source thing, but there is a team which creates us these modules to do load testing. I think there is Apache Locust. Also, yeah, Locust. If you see locust.io, this is what we kind of use internally.
Can you send the link?
In chat. How do I open the chat again?
Yes, thank you. This is pretty interesting because, as you were saying, everything needs to be happening live. So I guess that the load test is a very important part of making sure that your service is up and running, available for everyone.
Any other last questions?
Are there any more questions? Otherwise, I would say that we close this up now. we're also already almost at the end. And so just a few more notes. So, I mean, yeah, first, thanks very much, Vaibhav, for presenting. I found it very interesting. I would have more questions, but yeah, seeing that the time is like already advanced. So yeah, also thanks for the audience. Thanks for asking questions. And a note, so there will be the second data lift happening in November, the 27th of November, also at 11 a.m. Friday again. And you can register now via Eventbrite and LinkedIn. I think the event should have been posted, so you probably should have received one already. And otherwise, yeah, thank you very much for participating and for having been here.
Thank you, people. If you have any questions, please reach out to me personally or DM me on LinkedIn, and I'll be happy to answer you. Thank you.